This is a production of Cornell University.
And I'm Kirsten. I manage the actual lab itself. And this is our greenhouse. So this is where we do the root bioassay. The root bioassay is a way for us to look at the amount of fungal pressure, specifically diseases, that may be present in your soil. I'd like to first clarify by saying that most of the diseases that we look for, which is Pythium, Fusarium, Bioassay, and Rhizoctonia, are present in most soil around the world, right? We already know this. They're not all everywhere, but one of these is probably basically everywhere. So what we're actually measuring is the health of your soil and the ability for the plant to outgrow that disease, right? We're not going through and looking and saying like, yes, I can identify Fusarium, for instance, right? I know, I look at it like, yeah, that's Fusarium, but I'm not going to contact the grower and say, I saw Fusarium, I could be wrong, you know? It could be something else, who knows? I'm not a plant pathologist, I'm a soil person, right? But what I can say is that you have less or more pressure on your actual plant itself. So what we would do is we would assign them a rating. The ratings are based from 2 to 9. You might wonder why isn't it 1 to 10? That's basically because 1 would be a perfect plant. We don't think that really exists. And 10 is completely dead, completely failed, absolutely nothing. So we keep it more in that range, right? So typically the best rating that I give a plant is a 3. Some of them get 2s. If it really fills up the tube, you guys will have a chance to see what this looks like in a minute. But typically 3, if you get a 3 or a 4, your soil's doing great. That really means that we don't see any evidence at all, right? If you get something more like a 7 or 8, that's a really serious issue. That's telling us that you then, your agricultural consultant, if that's you guys, or if you're the grower, that means that you need to send your soil to a pathogen soil testing lab and figure out exactly what you have going on, because there's different management strategies for these 4 different types of diseases that we look for, right? So we grow these beans in this highly stressful situation on purpose. It's very hot in here. A lot of these diseases are encouraged by high soil temperatures. And they get really dry, they get wet, they have all sorts of stress. They're in these white tubes. So we expect that if there is evidence there, if your soil's not strong enough to outgrow it, we're going to see it. We also use these high-style snap beans, which we know are highly susceptible to these diseases naturally. These seeds have been treated with various things. There's a list right here on the seeds, but, Captan, streptomycin, kind of the standards. Part of the reason for this is because most people are using treated seeds these days. The other reason for this is that if your plant is still getting these diseases when working with these treated seeds, that's really telling us there's a major issue there, right? If we didn't treat these seeds, these plants would not survive. Some of them kind of would, but it would be really, really hard. So over here you can see, all day long we've been talking about the intensive management and the sod, or good Caldwell, bad Caldwell, that's what we call it, it's our shorthand in the lab. Once again, this is good Caldwell, bad Caldwell. And right away, I think that you can see a visual difference. These were planted on the same day. These also were planted on the same day. These I pulled from, I had about 200 samples sent to me earlier this year for this test. We do all of our tests a la carte, right? I don't think we really specify that, so I want to make sure everyone knows that you can send in just for available water capacity if you want to. So these had very bad ratings. These were all 7s and 8s. So I planted these on purpose in hopes that we can see some evidence of disease, so I can show you kind of what we're looking at. That said, these have only been growing for about 3 weeks. Typically we don't harvest until 4 or 5 weeks. So the evidence is very light. You're just starting to see some evidence here. If I had planted them sooner, if I wasn't so busy with our lab becoming extremely popular, I would have gotten these out here sooner and you would see a little bit more evidence, but we've been looking at them all day and we are seeing some issues. So you should be able to see that. So each sample gets 4 reps. So for instance, these are, like over there, those are actually soil health samples that I can tell you right now are having some serious issues under the surface of the soil. I don't know what yet, I will next week. But if we don't get enough soil, they only get 1 rep. So this is something, as a lab manager, I really have been kind of pushing this all day. We really need enough soil. It's really important. You're going to get better data, and it also costs us a lot of labor to have to stretch the soil out, right? So for instance, these guys are, those guys I had to replant because they were total failures. The ones where you don't see anything coming up. So I will replant up to 3 times. After that, I'm saying, like, okay, the seed is over 90% germination rate. I'm pretty sure that you got a really serious issue going on in there, right? So then you can see these guys didn't quite set themselves soil. They only get 3 reps. We take the average of the 4 reps, assuming they send us enough soil, and that's the result that the farmer or the agricultural service provider receives. So, do you guys have any questions before I kind of move into showing you how they actually do this? No? But I think that the main point about this test really is that we're testing the suppressive capacity of your soil, right? We're looking to see how healthy that soil is and if it can actually push past that. We're not testing how much pathogen pressure you have, although of course that is a factor and that's going to influence this. We're really truly just looking at whether or not it can power through that. All right, so what we do is we use these, we call them bean tubes. I believe that these are actually used for starting trees, generally. And we take clean cotton ball, we place it in the bottom. The purpose of this is to ensure that it drains properly and also to keep the soil from falling out. We're one of the only greenhouses on campus that actually use soil in the greenhouse. Most people working in greenhouses are using media, various things that have been sterilized. As you all probably know, there's a lot of potentially dangerous things in soil, especially for greenhouses. Some of these issues that we look for really are huge problems in greenhouses. Anyway, right? So I'm very careful to keep everything extremely clean. This is a very clean greenhouse. It's sterilized regularly. All of these racks and these trays I sterilize between every batch to just minimize as much as possible anything spreading and throwing this off. That all said, this is really a visual test, as you're going to see. You can see with this picture over here, we're really looking at kind of the big picture with things, right? We're looking at, so this would probably be a 3 or a 4, probably a 4. If it was whiter, I would probably give it a 3, and this is probably more like an 8. I see them look way worse than this, So, it gets into the 9. 9's pretty much a complete damping off failure. So that's kind of an idea of how the ratings move. This isn't the best picture. You can see oh, well, this is darker than this. Wouldn't that get a worse rating? But then if you look more closely, you can see the darkness moving up the stems. And this is evidence of the specific things we're looking at, right? So these are pictures of actual samples that have come through the soil health lab. You can see the pythium, something that a lot of us are probably pretty familiar with. The damping off, and then the fusarium, which was probably what was going on. In this picture would be my guess. Like I said, I'm in soils, not plant path, but I'm learning more and more about it every year. And then we'll see the lesions. I've had some samples come through here where the lesions are all the way up. They move all the way up the plant, and then that's going to be in the 8, 9 range. And then if they call us, their agricultural consultant should be telling them, look, you need to send your soil to a path lab to figure out what's actually going on so you can actually manage risk. It's kind of another example of something where this would be more in the 3 range and this would be more in the 7, 8 range. And we see stuff like this all the time. So what we do is we take our soil. This is the good Caldwell, bad Caldwell again. Forgive me for shortening things, but I do it with everything up here because it's lots of big words and lots of talking, and it just is easier like that. So I do kind of want to point out this soil just because it's fresh, and I think that there's a lot to be learned from fresh soil. We actually pull, as soon as we get the sample in, we pull it that day or the next day and we get it right out there in the greenhouse, because this does take the 4 to 5 weeks. That's another refinement I started this year, just to try to like help us get this stuff out as quickly as possible. Although, yeah, this is the world's most comprehensive soil test. It doesn't happen overnight. That's just how it goes. But you can see some differences here, I think. If you look at it, just right off the bat with the color. You know, the good is much darker. You can see that the organic matter is much higher visually to this one. You know, and it's like, of course, I know I wish that we had time to show you guys the field so you could see this field, which has been in wheat for 20 years or something like that. And the wheat was like this tall. I mean, it's terrible looking, nasty field, cracking, all sorts of issues, flooding, versus the sod is doing great, no problems at all.
Okay, now that you bring it up, I have to say, why are they using continuous wheat on this field that is for a particular torture test?
I think that it's some kind of a long-term breeding something, but I'm not sure. I'm pretty sure it's one of the breeders' fields. I don't know what they're doing exactly. But yeah, that's kind of one cool thing about campus is that, especially Bob, he really knows. He's been here forever. He knows these fields that have been basically abused and beaten down for as long as he's been here, so 30 years or something crazy like that, right? Or 35, didn't he? I think he started in the 80s, early 80s, right? So he knows the history of a lot of these fields. So we'll go and like pull some soil because we know that what it's going to do, basically. We can predict that, and he was right, you know, we ran it, we pulled it, we ran it through the soil health test, and you know, you guys all saw those reports, I'm sure, they're right there behind there with the air-dried soil, and you can really see it's an extreme difference in these areas. We're right next to each other, you know. Just, we love to talk about how the management actually is affecting the soil. It's a really phenomenal thing, I think, especially for people who are not exposed to this. All right, so basically though, what we do as far as the actual planting is we take the soil and we run it through a 4mm sieve, right? Just a bit. Just like a little bit, the rest of it I knock out and I put to the side. So this soil has gone through an 8mm sieve. You can kind of see it if you're familiar with sieving. I am. I can kind of look at this and say, we do a lot of sieving, you guys. Not as much as we used to. I don't know if you've seen the grinder yet. Down, you guys been to GO1? Right, so that's a new innovation this year. That was all Bob, and that has saved us so much time on sieving. It's like my first year or two, I swear that's all I did. I felt like sieve soil. Anyway, okay, so we take the soil that's gone through the 8 and we put it in a labeled tube, of course, you know, and then we have 4 reps. We just label the first one. And typically when I do this, I keep my bag of soil in front of me or encourage any of our techs to do the same so that you don't ever like lose track. It's like the #1. We're a little bit hardcore about no mistakes here, but you pretty much have to be. It's like whatever, triple checking. I say that all the time. I probably drive me crazy, but it's really important. You literally triple check everything. So I take the seed and I put it on its side. Basically, this is really important because it seems like such a simple thing, but if you have it kind of facing up, it'll actually send its roots out first. It'll just have such a harder time. We've learned so many tricks to help encourage these to grow in what's naturally a highly stressful environment, right? And then I just take about ½ inch of soil, the sieved soil, and I put it on top. Just kind of trying to make this like easier for them. I want them to just be able to pop out. I want them to germinate in a day or two. You know, which they will if they're properly taken care of, and then they go on the rack. They're always positioned like this, and then every other row, so that they have space and we can avoid any cross-contamination when we're watering them, right? So I water these beans personally by hand with a hose that I have set to go right over there. You know, we kind of have it down a little bit. I put on a very low volume, and I come out here every single day, even Saturday and Sunday, and I water these because I have a strong background in agriculture. I have an organic farm. I have a green thumb. Not everyone does, and they have gotten killed by people forgetting to water on the weekends, and then you have to start from scratch. So to me, I live in Fall Creek downtown. It's not that big of a deal to drive up here to be sure that they're going to be alive. So that's just a little part of what I do. But right, so then they're planted. They're grown for 5 weeks. And then they're harvested, which I can show you guys over here what that looks like. So these are all the good and bad Caldwell. And then these are the a la carte samples that I received earlier this year that had really terrible ratings. So I'm hoping that we're going to see some evidence of disease. You can see that these are all really wilty. This is because I didn't water them this morning on purpose in preparation for harvesting them, so that the soil will just fall off the roots and it won't break off. So this is another thing, kind of a learning curve thing that we learned to just save time. I'm super obsessed with efficiency. We're all obsessed with just trying to make this as unlabor intensive as possible. It's not the best way to put it, but I think you guys know what I mean. All right, so I loosen up the tube. I just whack it out of there. And then typically you would throw the tube down to the end. This is usually a two-person job. One person would be doing this part of it, and the other person would be doing the washing. So then you would lay your tube with the samples right next to it in a very specific way, and then the person follows along and washes the roots. So this is the good Caldwell. Right off the bat, I can tell you I'm seeing good things. I see these are kind of shaped like the tube, right? I see that it kind of filled the tube out. It's not just this little piddling of a root. So then we go through and we actually wash them by hand. This is a really important step because I personally rate these beans. I assign them their rating between 2 and 9, and then Bob Schindlebeck comes and he checks my ratings and almost always adjusts them. Because he's been doing the ratings for these since the beginning of the test. This was part of the original package on the test in 2007. So we want to be sure that it's consistent. We wouldn't want a farmer to get a 7 one year and get a 6 another year if they affected it, if that's not actually true, right? So because it is a visual assessment, because it is, you know, something that you could kind of have a bias towards perhaps, you know, we're very careful to double check it. So I'm going to pass these around. These are good. This looks clean to me. I don't see, I maybe see a tiny bit of evidence right there. Looks like a little bit of darkening. But I'm not seeing much. I bet this is around a 3.5 or 4. And then in contrast, we've got the bad Caldwell, which we don't know. Because I haven't, when we ran this for the soil health test, we didn't actually do the bean root bioassay because of course it's not included in our standard analysis. So we don't know until now, and I'm going to leave some in here out of my own curiosity to get to their full age so that I can determine how much disease pressure is actually on these. So I'm going to keep these alive for another probably week, and then I'll harvest them and give them an actual rating just so we know for our own reference. All right. That Caldwell. All right, so this one for some reason had 2 seeds in it. It's not exactly the standard, but it doesn't really matter. But I think right off the bat we can see a little bit of a difference, right? So I'm taking this into consideration. I'm not really looking at the plant. You know, like what I showed you guys with looking at the plant overall, that's not something that we do as part of our assessment because what are we going to compare it to, right? But as far as just my own curiosity, I'm taking that into consideration. And I definitely, for this purpose, am going to be looking at these compared to those. So, definitely, I can see some evidence here. But less roots, exactly. Yep, and we can see some dark spots. See that starting? So in another week, I guarantee that this will look nasty. You can kind of look at it along with those, and you can really see.
There's this computer program that design measure at least biometrics.
Yep.
That takes too long.
Yep, it would take too long. We've of course talked about that. People have talked to us about that. I think that would be really interesting in general. I think that's the kind of thing that you could, if you're a researcher, maybe we tell you we see some pressure, then you can take those next steps or send it into the cath lab, right? So this is kind of a way, it's like canary in a coal mine. We're saying like, look, we can see some evidence, we need to then take the next step to see what's going on, right? We're not going to tell you like anything specifically about these.
Yeah, but do you grow controls at the same time or just?
Not exactly. We do grow the same, we grow soil that we know what to predict from regularly, like in our research plots and things like that. But yeah, we don't, this is actually the only test that we don't have a quality control with every batch. I've thought about it, I don't know, I might do something like that in the future, I'm not sure. But it's been discussed. I don't know how much it would necessarily influence things, because what are we going to do, get some like pythium infested soil and grow that along with the, I don't know, it's a tricky thing, but yeah, I've been thinking about it, maybe in the future. Okay, so these guys, like I said, they've only been in here for 3 weeks, but at the 5-week mark, they had really, really terrible scores. So, I think right off the bat, we can start to see some issues even at the 3 weeks, right? These marks, that doesn't come off. And then you see how this is thinning there? Not a good sign. Definitely not a good sign. And then also the overall volume of these goods. Okay, so looking at the goods compared to that.
That's our mental control, really.
Exactly. Yeah, well, we do enough of our own research that we have stuff out here.
Probably go over your dad's.
Definitely, yeah. It's kind of like, I mean, I've harvested thousands of these. Thousands. So I sort of have a database in my mind of where it falls in. As strange as that sounds, that's really how it is, you know? But you can really visually learn quite a bit from just looking at these roots. We do think that it's really a valuable thing. It's kind of a thing that we think is more specific for specific people these days. It's not part of our, standard test anymore. It's just in our comprehensive or as an add-on. So if you're a vegetable farmer, you probably would really want to do this. We would recommend this to you if you're a vegetable farmer. Yes, we see nodules all the time. I've thought about, we've talked a little bit about maybe marking down if we see nodules or not, kind of as an additional thing. It's a tricky thing. There's so many more things we could do with everything that we do up here, But then we're trying to get these results out as rapidly as possible, and we're dealing with a unprecedented volume of samples. So that's something we definitely talked about. We've also talked about doing weed seeding a little bit, and like actually super long term and look and see what kind of weed pressure. There's been some talks, mostly from outside of our team, people approaching me and asking me if that's something I might be interested in looking into someday. And there's a lot of, that's kind of the cool thing about this. We're always refining our tests. We're always improving our tests. We're always looking for new and novel ways to show and talk about what we're interested in.
But that's a good thing. That's you have to do that.
Exactly. Yeah.
You have to be that.
Yeah, I think so. I think it's really important. Yeah, and this test changes every year. I mean, this year we did a lot of things. We came up with the grinder and the sieve. We changed the way that we can get the water for the accurate stability, the texture sync. I'm sure Jamie showed you that, which her and I designed. That cut our texture time in half. Removing this from the standard package, that saved us a lot of time. Moving to this greenhouse. Originally, we were in an insectary, which is halfway, it's like half a mile away that way. So my first year as a temporary lab tech, I had to push bags of soil on a cart across campus, soaked in sweat through all the undergrads, you know what I mean? We're like, whoa, who are you, So, that was pretty fun. Yeah, right. What I say, my friends call me a dirt nerd,
This has been a production of Cornell University, on the web at cornell.edu.